Okay, yesterday I explained till this title circuit breakers and the resettable guardian. Today I will continue from this point and we will explain how these equipments and these facilities can protect our life. Okay, so before that I wanna show two videos for you. One is about the fuse and one is about the circuit and about their functions, how they function. And you may first watch the video, then we will talk about the function. First let me find the video, then we will continue with this part. Okay, do you have my screen? Okay, now let's see that how circuit breakers work and how do they function. We will listen about the functionality of this one, then we will have one video about the fuse, then we will continue our slide.
Have you ever wondered why the switch on some of your appliances is different than other switches, or why do we Have you ever wondered why the switch on some of your appliances is different than other switches, or why do we have this box with wires going in and out? Well, in this episode we are going to answer these questions. These devices are known as miniature circuit breakers, or MCB in short. They are used for protection against overload and short circuit, and they have distinct mechanism for both the operation, which we are going to explore. This MCB has C16 written on it. Thus this is of class C with an overload current of 16 amps. Let's remove the rivets and open it. This is the input side. The phase wire is connected here. Then we have is a bimetallic strip. This strip is made of two different metals. When metals are heated they expand, and different metals expand at different rates. So when we heat two different metals that are joined, they bend, because one metal wants to expand more than the other. The heat to expand and bend can be generated by flowing a current, as the case in an MCB. Then we have is the movable contact. It is moved by the mechanism to turn on or off the MCB. The other part of the contact is fixed. Now from the fixed contact, the current flows in the solenoid coil. This solenoid coil is used to create a magnetic field that will push a plunger with a pin as required. Then we have is the output, which goes out to the appliances. There is also an arc or spark divider, which extinguishes the spark generated while separating the contacts. As these MCBs are used for protection against overload and short circuit, let us look at both cases. First, we will see the overload situation. When the MCB is on, the current flows through the bimetallic strip, and thus the strip starts bending. Its bending depends on how the strip is manufactured, thus different strips bend by different amounts for the same current. Also, the bending of the strip depends upon the heat generated by the current through it. This graph gives the time when MCB trips versus current through MCB. As the current increases, the bimetallic strip bends. The strip then pulls the small plastic part, and this moves the mechanism. Then the springs help to break the circuit, so the time to break remains small, and the MCB trips. As the circuit breaks, the current through the bimetallic strip stops, and thus it regains its shape. At the same time, a spark can be generated between the contacts. This spark can damage the components, and thus it needs to be extinguished as soon as possible. Hence, we have as a spark divider. The spark divider is just a bunch of electrically separated metal plates spaced with the help of insulators. This spark travels towards the spark divider from the contacts with help of these guides. The shape of the guide is designed such that the spark travels towards the spark divider. This spark can break due to the increased distance between the guides, but if it doesn't break, then the spark is broken into small multiple pieces by the spark divider such that they would not be capable of sustaining the spark for a long time and it will be extinguished. You may also know that a spark is a plasma and it produces a lot of heat. This heat can damage the plastic casing, thus we have a ceramic plate below and above it which prevents any damage to the casing. The spark divider also helps to dissipate the heat produced by the spark. Now, let's see the short circuit situation. In a short circuit, a large amount of current flows through the MCB. As the current flows through the solenoid, it creates a strong magnetic field. This magnetic field pushes the pin placed in the solenoid. The pin moves the mechanism, separating the contacts, thus the MCB trips and the flow of current stops. A spark is also generated and it is dissipated by the spark divider. But why do we need two mechanisms to break the circuit? Let's see for the first case, that is, on overload and the circuit breaker trips at 16 amps using solenoid as the trigger. Now as the current increases beyond 16 amps, just for a small amount of time, the solenoid will push the pin and the MCB will trip. And you may know that some appliances have power spikes where they can draw more current than their rated value. So we need a mechanism that takes time to trigger and won't trip the MCB during small spikes. Thus we have this bimetallic strip. This will trigger when a small overload is for a large amount of time or a large overload is for a small amount of time. So why do we need this solenoid trigger, as the bimetallic strip may protect in a short circuit? Because the bimetallic strip takes time to heat up and expand, and during a short circuit, time is very important. A short circuit needs to stop as soon as possible, hence we have the solenoid to trip the MCB instantly. Now you know how an MCB works, but you need to use this electricity. Hence, watch this video on how the mobile charger converts AC to DC or continue watching one of our other videos. Thank you for watching.
Okay, so it was about the circuit. Now we have a short video about the fuse. Okay, so how fuse works and where do we install the fuse. So you may just listen and then after 2 minutes we will go on with our own presentation.
In the last two videos, we have been looking at some of the advantages of the fact that electric current heats up objects through which it flows. Electric water heaters, light bulbs, and electric iron are few of the electrical appliances that make use of this fact. However, it has its drawbacks too. For instance, if these appliances are overheated, then they may get damaged or even catch fire. In fact, not only these appliances, every appliance in our house is affected by the unwanted high electric currents. There is a limit to the amount of electric current that any device can withstand. If the current exceeds that limit, the components of the device heat up and this may even lead to fire. So is there any way to prevent that from happening? There is a device which is used to prevent this and it's called electric fuse. Well, it comes in many shapes and sizes. This is what it generally looks like. It has a fuse wire and is connected to the two terminals which are made up of some metal. This wire is made up of zinc, copper, silver or aluminium. The rest of the switch is basically made up of a non-combustible material. And it makes perfect sense too. We should make sure that the device which is used to prevent fires in other devices must not catch fire. Now, how does it prevent household electrical appliances from catching fire? Well, this fuse is introduced in every circuit in our household. This is how the basic circuit would look like. We have seen this simplified circuit in our previous videos. Okay, so when the current flows through the circuit, it heats up the fuse wire. And when there is a heavy current in the circuit, the wire simply melts, resulting in the broken circuit. Yes, the circuit breaks and the current does not reach the appliance. So this is how an electric fuse functions. Simple, isn't it? Now there is one obvious disadvantage of electric fuse that you must have noticed. Once the fuse wire melts, it cannot reform itself. We have to replace the fuse with a new one manually. To overcome this problem, automatic fuses are used nowadays. They are also called miniature circuit breakers, often abbreviated as MCB. They work like automatic switches. Whenever there's an excess amount of current flow in the circuit, they automatically switch off. This breaks the circuit and the appliances are saved from excessive current. They also automatically get switched on when the flow is back to normal.
Okay, as you have seen the video, now let's talk about the circuit breaker. Okay, so here no need to think about the function because the functionality of this equipment is very difficult, and no need to think about each part of this one, but how does it function and why it is very important. It is as you can see, it is resettable. What is the meaning of resettable? Yes, you may open your mic and continue.
Sir, it means it when it melts, it can fix itself again.
It will not be melted, but it can be disconnected. Okay, it can be disconnected and disconnect the electricity. Resettable means that we can press the button and we can use it again. Resettable. Yeah, thank you. And what about the guardian? Guardian means protecting our life. Okay, protecting or saving our life. Guardian means protection. And it is resettable. It is very important. For example, if the current is overloaded, means that if we have too much of the current, the electricity, as you have seen in the video, so we will have a lot of heat inside this one. When we have heat, so the value or the amount of this one will be increased, and the electricity will be disconnected automatically. So after that, if for example the problem solved and we have normal current of electricity, we can reconnect by pressing the button. Okay, resetting button, then we can reconnect this one. And why this is very important and fuse is not very important, because in fuse they will be melted and we cannot use it again. Okay, so it is when it melted, so we cannot use the fuse. But the circuit breakers, it is usable and we can use it for the next time, for many times as well. Just you should solve the problem and then you may connect it. Okay, so here we have fuse and we have circuit. What is the difference? And here what is first one is mechanism, and the mechanism intentionally inside the fuse a very thin melting wire is connected and installed. And in circuit breakers mechanical trip switch, so there will be a mechanical switch, automatically will be connected and disconnected. There will be no melting point. And location, where do we install this one? This is one of these two. Okay, inside individual plugs. For example, inside each plug, which is important, will be installed. Okay, and next one, consumers unit central panel. For example, you usually connect these circuit breakers inside your home, the place that you are receiving and you are taking the main power or electricity. Action upon fault, okay, blows destroyed itself. Okay, when the electricity, when the current moves, so overloaded will be this one, the fuse will be destroyed by this itself, and they will stop the current or electricity, automatically opens the trip. And there will be no distraction, there will be no melting point, just automatically will be disconnected, the electricity will be disconnected in the fuse. Okay, so recovery. and must be replaced. Okay, in fuse we cannot recover and we cannot fix it. On that time you should replace it and you should change it. And in circuit breakers, yes, in here you can just by pressing the button you can reconnect it and you can use it for many times. Okay, and here we will talk about the earth wires. For example, here it is an electrical kettles. Okay, electrical kettles, and in here in the first one we do not have earth wire. So inside the kettle, if we face any types of problem, for example if we have electrical wires overloaded, so of course that inside the kettle we have for example some wires and they will be melted, and some parts of the electrical kettle may be connected to the current. On that situation, if we have wire earth wire, this earth wire may connect the extra or the overloaded current to the earth and there will be no problem like the first picture. But in the second picture, okay, in the first picture the person, when another person may touch this kettle, so they will be they will face electrical shock. In the second picture we have a wire which is connected which connects the kettle to the to the earth, and this extra current will be guided to the earth, and the earth may take the current and they will solve the problem and they will take the extra electricity. On this situation, most of the time if you want to provide some electrical gadgets or equipments, and you should check whether they have earth wires or not. Okay, so if they do not have, you should think and you should pay attention, because there will be a potential risk for your life, because sometimes we are in need of connecting the electrical equipments or gadgets to the earth or ground. Okay, so here we have the chain reaction, how earth and fuse work together to protect our life. Okay, so here we have many objects, many things that they can work together and they can protect our lives. For example, first we have the fault. Okay, when something wrong happen in your home, if you have, for example, circuits, in the circuit may disconnect your electricity and they protect your life. And then after that, if we have earth wire, so this one also may solve some problem. And if we have, for example, fuse, so fuse also may solve this problem. Many things work together to protect, to save our life at home. But if you have one of these three, so your life will be in more risk and danger than if you are having these four of them. Okay, the four of them will protect your life more. Okay, your life will be safe and your home will be safe. And next one, sometimes if you have double insulation, sometimes, for example, this is a kettle, and in this kettle we have what? Insulation. Insulation means the plastics that we are using as the cover of the electrical gadgets. Okay, and if we have only a single cover for this one, this is called single cover or only one cover. But if we have two, so this is called double insulation. Most of the time double insulations, they resist against the heat, they resist against the electrical current. So in this time the risk of electrical shock will be less. But if we have only a single cover, so single cover will not or cannot resist against the electrical current. Next one we have gatekeepers and critical placement of switch. Sometimes we have some switch. If you have noticed, some people are installing this one, installing out of their home. So this is an electrical equipments or gadgets, and they will be installed out of the home, and they do what? They regulate the amount of the specific amount of the electricity which will be transferred to your home. And they usually do not let too much of electricity, no, overloaded, or this one less than the normal electricity which will be introduced, which will be entered to your home. Okay, and we have two types of wire, and one is live wire, and the live wire is the first one. Okay, in the first one you should install the this one, the gatekeepers, in the live wire. But if you install in the second one, in the second line, so in the second line they cannot control the amount of electricity, because the current or the electricity may come from this one on the second wire is the wire that which can guide the electricity back to the main source. So that's why you should install the electrical keepers in the live wire. In the live wire they exactly regulate the amount and let the specific amount of the electricity which will be transferred to your home. And we have different parts of these gadgets, and they work together to protect our life. First one, for example, electrical gatekeeper, protect your life from outside. Okay, so here you have installed here, and this switch may protect your life. And next one, inside this we will have fuse. Inside the plug we should have fuse, and out of that we should have, for example, in the gadgets or equipments that you are using, and they must be original, and we should have insulation. If we have double insulation, so it will be great. And then we will have we should have circuit breakers. So these all things may work together to protect our life. So this was all about how to protect our life against the current or electricity.